Hey there, here is part two. These are going to be two problems that should be fairly quick, but what we're going to be doing now is we're going to take all this information, we're going to put it together, and now we're going to see if we can actually create our own graph with a table and just using the A, B, and C values in order to get this entire picture. So let's get started on this, okay? Take a look at number 3. What we're looking at here is we're looking for the A, B, and C values first. So we've got a 1, a -4, and a -3. The axis of symmetry, remember, is just x equals -b over 2a. So the opposite of b is 4. 2 times a is 2 times 1, which means we can 4 divided by 2. So our axis of symmetry is x is equal to 2. So we can actually make this line so we can at least see what this is going to look like. That at x equals 2, we're going to go ahead and have this imaginary wonderful line right here. I'm going to go ahead and make it a dotted line. Just because I want to keep consistent with what we have on decimals. Okay. Let's continue with our vertex here. That when we're going to take that 2 and plug it into our function, we'll get y is equal to 2 squared minus 4 times 2 minus 3. So we are going to end up with y is equal to a positive 7. I'm sorry, a negative 7. My apologies, negative 7. So we're going to be at 2, -7 for the vertex. Now, there's a trick to doing this table, and actually you only have about half of the work that you actually need to have. Oh, let me put in 2, -7 first, okay? We know we're in a good shape because the point is directly on top of our line, okay? But let's take and put our vertex in the middle, so 2, -7. Now, we're going to have symmetry in this, and whatever we have on the right side, we're going to have the same thing on the left side. So this is the way I do my table. You ready? Whatever the number is that we have right here in this first spot, we're going to go 2 up from there and 2 down from there in terms of the values, okay? Or basically 2 values to the right and 2 values to the left on my picture. So I'm going to use 1 and 0, just counting backwards, and then I'm going to go ahead and use 3 and 4, counting forwards, okay? And what we should find is that whatever we have for this spot right here, since there's symmetry, it should be the same as what's in this spot here. And then whatever is in this spot here will be the same as what's in this spot here. Okay? So we should only have to do one of the pieces of work. Let's see what happens here. If I put a 0 in for x in my function, that means we're taking the 0 and putting it in for the x's in these problems here. What we're going to get is a 0 squared minus 4 times 0 minus 3. That means we're going to have a -3 when we simplify that. And down below, we should have the exact same value. That's that symmetry we just talked about. If I use a 1 in my function, 1 squared minus 4 times 1 minus 3 is going to equal 1 minus 4 minus 3, which will be -6. And again, since we have symmetry, it'll be the same thing on the other side. So watch what happens when we graph this. Right now, when we just look at the picture, I can't tell you if the graph opens up. I can't tell you if it opens down. We don't know if there's a max or a min taking place here. But with some points, we can easily tell this. So when I put in 0, -3, whatever point we have on the left side, since there's symmetry, we should have the exact same point over on the right side. See how it's 2 away here? It's 2 away in this direction as well. Well, that matches with what we got here. We have 0, -3. We have 4, -3. That's these 2 points that are right here, symmetrical with one another. Okay. Let's go to the next point, which is at 1, -6. That's going to be right here. And the symmetry will mean that we'll have the exact same thing on the other side. They're symmetrical. Now you can see with these 5 points which way our curve is really going to look and turn. It's going to look something like this. Okay. And then the last question here is the vertex a max or a min? Well, let's look at this point. It's down on the bottom, which means it's the smallest that it will go. So this is a minimum. And then the beautiful thing is we've got decimals. We could check all of our answers here. So if I go to decimals and take a look at x squared minus 4x minus 3, this is what our equation looks like, our picture. And then our symmetry is x equals 2, goes right through it. And we look at the vertex, we can see it is in fact at 2, -7, which is like what we just said. Okay. One more down here. And this one's a little bit tougher because we're missing a value here. If I was to write out this value here, I'm sorry, this equation with everything accounted for, we would have -2x squared. There would be a 0x and then a positive 7. Remember, whenever we have something missing, we said there's 0 of it. Put your A, B, and C values in. We got negative 2, 0, and 7. Your axis of symmetry is going to be x equals negative 0 over 2 times A, which is negative 2. 0 divided by anything is just 0. So we get an axis of symmetry of x is equal to 0. My vertex, let's plug it in. We're going to have negative 2 times 0 squared plus 7, which means we're going to have 0 plus 7, or just 7. So my vertex will be at 0, 7. We're going to plug our vertex in the middle of this. We're going to go 2 down and 2 up from there. So there'll be negative 1 and negative 2, and then positive 1 and positive 2. Let's go ahead and substitute these values in to see if we can get some actual y values. So we'll have negative 2 times 2 squared plus 7, which means that this will be negative 2 times 4 plus 7, which will equal a negative 1. And whatever we get there, it should be the same thing on the other side. Okay, let's go ahead and use 1. So we'll do negative 2 times 1 squared plus 7. So we have negative 2 times 1, because 1 squared is just 1, plus 7. That means we end up with a positive 5 here and a positive 5 here. And that's it. That's our table. So let's plot all these points and see what we end up with here. Okay. So plotting our points, we're going to have a vertex at 0, 7. We have an axis of symmetry of 0. So x is equal to 0, which will look like this. Again, I'm going to go ahead and make that a dotted line. Okay. We have a coordinate at negative 2, negative 1. Come on. Choose it. There we go. Negative 2, negative 1. We've got negative 1, positive 5. We've got 1, 5. And then we've got 2, negative 1. We see the symmetry. So this is what our curve looks like. And that point, that's at the top. Now, this is the top of our picture. Therefore, that is a maximum that is taking place. Okay? And just to confirm everything we've done, we're going to go ahead and take a look at our picture. Last one. We have negative 2x squared, which looks like this. We put in our axis of symmetry, which will look like that right down the middle. We touch the point at the top, and we can see it is, in fact, at 0, 7. Give our practice 1 a shot. You just use this as your guide to follow, and you'll see that's pretty easy stuff to get through, okay? Thank you, and you take care. Have a good day.